Well, good day, students. Here is a brief video on the indices of variability or indices of dispersion. We're going to quickly work through some computations here to review how to compute the observed range, the sums of squares, the variance, and the standard deviation. So again, what you should do is copy these PowerPoint slides into your notes for future reference or for practice. So you should work along with me here. So if we take a look at some IQ scores. We have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 scores here, so the sample size is 8. We can start by computing the mean, the median, and the mode. So you should be able to do this on your own. So if you want, you can pause the video here and quickly compute these and then check your answers. So if you determine the mode, we can see that there are two 91s, and that's pretty much it. So we do have a mode that's defined. It's 91. Compute the median, you rank order these data or rank them from least to greatest, 85 up to 110. These are the two middle values here because we have an even sample size, and so you split the difference, that's 99.5. To compute the mean, sum the values, so 783 if you add all of these up, divided by 8, and that gives you 97.88. And remember, I want you to remember this formula, the sum of x over n, and of course the symbol for the mean is x bar. So now let's move on to the indices of variability. So that will be the observed range, the sum of squares, the variance, and standard deviation. The observed range, pretty simple. Take the maximum value minus the minimum value, so 110 minus 85, and that gives us 25. Now we go to the sum of squares, and this is another formula I want you to memorize. So memorize this formula, memorize the mean formula, and on the first quiz, I'm going to ask you to compute these indices. So we'll start out with our variable here, IQ, and we'll copy the data here vertically because it just makes it easier to work through the problem this way. And then we will get our square deviations about the mean here. So our first value, 91, switch on the calculator here. So 91 minus the mean, which is 97.88, and that gives me negative 6.88. Now I need to square that. In this calculator, I'm just going to have to multiply again by 6.88, and that gives me the 47.33. I see that value here. The next value should be 165.89. Let's see how I obtain that. So 85 again minus the 97.88. That gives me negative 12.88. So again, to square it, I'm going to multiply by 12.88. And that gives me 165.89. So you take each value, subtract the mean, and square the result. And that's how you get these values for this column. So here are the remainder of those values. Now I'm going to add these up in my calculator. And when you do that, you get 480.84. So capital sigma here means to sum. So what did I sum? I summed these values. I got 480.84, and that is our sum of squares value. So that's an index of variability. How spread out are these data? I see variability here. How much variability do I see? Well, it's 480.84 sum squared units about the mean. Not a very user-friendly statistic. So let's convert it to something a little more user-friendly. We can start with the variance, so that's a little less squared, and that's simply the sum of squares over n minus 1, so 480.84 over 8 minus 1, or 7, and that will give you 68.69. So now the variability about the mean, kind of on average, is about 68 or 69 squared units, IQ units. Again, not user-friendly, so we're going to go ahead and take out the square, and that will give us the standard deviation. So take the square root of the variance here, and that gives me 8.29. So now I can say the scores are spread out on average about 8.29 IQ units. So not a lot of variability, but a bit of variability among the IQ scores here. If you're familiar with how IQ scores are scaled, the mean is typically 100 and the standard deviation is typically 15. So this is less than 15, so there's not a lot of variability among these IQ scores, and we can sort of eyeball them and see that that's the case. So remember, the standard deviation is in the original units of measure. So I can look at this and talk about IQ units. This would be squared IQ units. So this is the most user-friendly metric for describing the variability in your data. Now let me quickly show you the statistics calculator because I want you to learn your calculator in a similar way, and we can see how we can get a lot of these computations done quickly. So I'm going to switch on the calculator, and now here, the Windows calculator, I'm going to switch it to the statistics mode. And I'm going to enter these numbers now, so 91, add that to the list, 85, and so forth. Okay, so I have all the values entered here, the count here, the sample size is 8, and now to get the mean, I just select the mean key. And there it is, 97.875 or 97.88. And then now I can get the standard deviation. Notice the sigma here. I'll talk about this a little bit later. That's another symbol for the standard deviation, but it's the population standard deviation when it's sigma n. When it's sigma n minus 1, that's the sample standard deviation. So notice here, the n minus 1 in the variance, take the square root of that. So that n minus 1 is what we want to use, the sigma n minus 1. So I select that key, and I get 8.288 or 8.29, and sure enough, that's what we got here, the 8.29. So simply by just selecting a button on your scientific calculator, you can get the standard deviation. Of course, to turn that into the variance, you would just square that, and that would give you 68.69. And if you want to get the sums of squares, you would just multiply by the n minus 1, and that would give you the 480.84 within rounding. So you can quickly work with your calculator to get the mean and get the standard deviation just by selecting the appropriate button. So be sure to learn your particular calculator and how to get these values quickly. So that is a quick review then of the indices of variability or dispersion. Let me know if you have any questions, and I will post a homework assignment for you to work through your own sample data set.